This is a continuation of subtracting fractions that are mixed numbers by using the borrowing method. All right, so let's go over an example again where we have a common denominator. Let's say we have 8 and 1/5 minus 3 and 4/5. Now remember, you can do this problem by changing each of those to improper fractions and subtracting, but I'm going to go over the new method here. So we're going to rewrite this by borrowing. So I'm going to borrow from the 8, 1 from the 8, which means I get to add on 5/5, right? One more. And that's the same thing as 7 and 6/5. So 8 and 1/5 is the same thing as 7 and 6/5. If you look at a picture, it'll be obvious. So I have minus 3 and 4/5. You don't need to write the new problem to the right. You could just subtract right here. 7 minus 3 is 4. And then the new numerator here is 6. Remember, you get the new numerator by adding the numerator and denominator. So I've got 6 minus 4, 4 and 2/5. Or maybe you rewrote it because it's less messy and you write 4 and 2/5. Now, of course, that's the same thing as writing it as an improper fraction, which would be 22/5. And if you'd have done this problem by changing each of the original mixed numbers to improper fractions, that's what you should have gotten. So let's quickly do it that way just as a verification. 8 and 1/5 minus 3 and 4/5. If I change both to improper fractions, that's 41/5 minus 19/5, which is 22/5. Right, so you've got options. Whatever way makes the most sense to you, whatever seems easiest. Let's do a problem where we have to get a common denominator as well. So let's take 9.5 minus 3 2/3. All right. I don't know if I'm going to have to borrow or not. You can't tell until you get a common denominator. So the first step here is to write each of these with a common denominator if you're going to keep them as mixed numbers. So I have to decide what the common denominator is for 2 and 3. Hopefully everybody's with me on that. That's going to be 6. So for the first fraction, 1/2, you can get that by multiplying top and bottom by 3 over 3. So it's 3/6. And in the second fraction, you're going to multiply by 2 over 2 to get a denominator of 6, 4/6. And at this point, notice you're doing 3 minus 4 in the fractional part, so you're going to have to do borrowing if you want to keep them as mixed numbers. Okay, so now we're going to go to the borrowing. All right. Let's see, if I borrow from the 9, if I borrow 1 from the 9, I'll have 8, and then my new numerator, well, if I borrow from the 8, that's 1 and 3/6, so that's going to end up being 9 for my new numerator. Remember, you can get that the easy way, adding the 3 and 6 together. Minus 3 and 4/6. All right, so what's that give us? Now we can do the 8 minus 3 is 5. And now I've got a common denominator, and the numerator at the top fraction is bigger, so no problem subtracting. 9 minus 4 is 5/6. That's the answer. Now, of course, like every single one of these problems, we could do this by changing to improper fractions. I like to do it both ways so that you could see what use whatever method you want. You could see it done both ways and then decide. So the first thing I would do is change to improper fractions. You could change it to a common denominator first as well. Let's do that. Maybe that's easier since I already did it here. It's 9 and 3/6 minus 3 and 4/6. And now I'm going to go ahead and change that to improper fraction. So that's 54 plus 3, 57/6 minus 6 times 3 is 18 plus 4, 22/6. And now I could subtract, and that's 35/6. And yes, that is the same answer as 5 and 5/6. You could also have first changed 9.5 minus 3 2/3 to improper fractions before getting a common denominator. That's up to you, which you want to do first. All right, let's do another one. All right, we've got 7 minus 2 and 5/6. All right, this is kind of tricky here. Notice you don't even see a fraction here. Common mistake is for people to go 5 and 5/6. Wrong. You're subtracting from no sixths. Okay, so don't do that. Okay, let's cross that off. Now we're going to do it right. 7 minus 2 and 5/6. All right, so if this is 0/6, it's easier to change that to just 6 plus 1, right? 7 is the same as 6 plus 1, so it could be thought of 6 and 6/6 minus 2 and 5/6. And that gives you 4 and 1/6. So if you have a whole number for your top number, change it to 6 plus 1 so that it just has whatever the common denominator is for the whatever the denominator is for the bottom fraction. Now, of course, you could also have done this by using improper fractions. All right, a little bit tricky. Let's see. Let's do the second number first as the improper fraction. 6 times 2 is 12 plus 5 is 17, 6. And that means I want to write this with 6 also. All right, so how do you write a whole number as 6? Well, you could think of that as 7 over 1. So you multiply the top and bottom by 6, 42/6. And then what is 42 minus 17? Let's see, I think that's 25, 6. Okay, is that the same thing as 4 and 1/6? Yes, it is. So that's a tricky one. It should be easier, but people, of course, make this mistake. I did it at first, which is wrong. So you have to be very careful here. Try one like that. All right, see how you do. All right, if we want to do it with the borrowing technique, we can say, well, that's the same as 7, and we want to change it to fourths, right? 4/4 minus 2 and 1/4, which is 5 and 3/4. You could also do this by changing both to improper fractions. Now here's another way you might find easier. I'm saying 8 minus 2 and 1/4. I have to think what I have to add to 2 and 1/4 to get 8. You know, addition is sort of the opposite of multiplication. So I need to know, like, what am I going to do with this? And some people could see, well, if I had 3/4 added to the 1/4, I would get 1. Okay, see if that makes sense to you. If I add the 1/4 and 3/4, so I've got 1. 2 more is 3, right? So I've got up to 3 so far, right? 3/4 added to 2 1/4 is 3. I need 5 more to get to 8. That is a totally different way of thinking about it, but perfectly okay if it makes sense to you. So let's do another one like that. See if you could do that in your head. What's 7 minus 1 and 3/10? See if you could figure out what you'd have to add to 1 3/10 to get 7. Okay, you need 7/10 more to get 1 more, right? So 1 3/10 and 7/10 is 2 so far. Add 5 more, and you've got your answer. So the answer is 5 7/10. Let's see, make sure that's clear. 5 7/10. So that's a kind of a totally different way of looking at this problem. Here's the last one for you to try. It does not have a common denominator, so you're going to have to deal with that aspect. And then you're going to have to see if you need to borrow or not and subtract. So use any of the methods I've gone over. All right, let's first do getting a common denominator. So 3 goes into 6, so I could keep everything as sixths. And that'll give me 4/6. 2/3 is the same as 4/6. Now I need to borrow. And so if I borrow from the 8, I get 1 and 1, 6, which is 7, 6. Get the new numerator by adding the 1 and the 6. And I could subtract 3 and 4, 6. And my answer is 4 and 3, 6. Now, the last thing is to simplify the fraction by reducing to 4.5. The other way you could have done this is change everything to improper fractions, get a common denominator and subtract, gotten the same answer. Or as an improper fraction, it'd be 9/2.